right, well, hello and welcome back to math. You will notice that Mrs. Hawkins has in front of you the screen or the page that we left off with yesterday. We've been working on all the different rules for divisibility. The first one we had to do was, here was the number you had to look at. You had to decide if you could divide it by 3. Some of you might have done the long division problem. Some of you went ahead and did the rules that we talked about. So for those of you that didn't pay attention yesterday, we have to write all of the digits down. And we had to find the sum, which means we add them all up. All right, so if I add all the digits up, we have here the number 21. Now remember the rule for 3 is after you've added the sum up, can this be divided by 3? Most of you know this can be divided by 3 7 times. The 9's rule is the same thing. Add up the digits. 21, can it be divided by 9? It cannot. All right, 2 is not the same rule. Remember the divisibility rule for 2 is, does it end in a 0, 1, 2, 4, 6, or 8? And it does not. Okay, so let's flip over and see how you guys did on these other ones. All right, let's see. Once again, we're doing the 3's. And to divide by 3, remember, we get to add all the digits up, which is 9. Can 9 be divided by 3? Yes, it can. The 9's rule is to do the same thing. Can 9 be divided by 9? Yes, it can. The 10's rule. The 10's rule, if you remember, is, does it end in a 0? Which it does. And so we have circled all 3 choices for this one. All right. The last problem you guys had yesterday for your homework was this one. Remember the 3's rule again. Add up all the digits. And so I get an answer of 12. Can 12 be divided by 3? Yes. The 9's rule is the same thing. Add them up. Can 12 be divided by 9? No, it cannot evenly. The 8's rule. Now, if you remember, the 8's rule is different. If you remember looking back or took notes on it, the 8's rule is we have to look at the last 3 digits of this number. So the last 3 digits of the number are 240, okay? So at least I don't have to do the whole number, but I do have to divide it by 8. And it did come out evenly. So I got to circle the 8. All right, so one of the things that your teacher is going to share with you, or maybe you wrote some of these down, is you're going to have a list that might look similar to this. These are all the rules. I'm just going to review them real quick. You will notice here a number can be divided by 2 if the last digit is a 0, 2, 4, 6, or 8. Okay, the 3, we know that a number can be divided by 3. We just practiced this. If the sum of the digits is divisible by 3, which means we have to add all the numbers up, and if it's divisible by 3 evenly, that works. The 4, you will notice we have a new rule here for the 4. It says the last 2 digits of a number are divisible by 4. So if I would have a 3-digit number, all right, so the 4, if you remember here, I said the last 2 digits. So if I would give you this number here, I want to know if that number can be divided by 4. Well, if I don't know how to do the rule, I would have to do this and solve this problem. If I understand the rule says to look at the last 2 digits, which is 28. Can 4 go into 28? And the answer is yes. So this big number would be divided by 4. This is the shortcut. Dividing it fully would be the long way. All right, let's look at the next one. The next number by 5 says if the last digit is either a 0 or a 5. So it doesn't matter how long the number is. As long as this last digit is a 0 or a 5, the number is divisible by 5. This number would also be divisible by 2 because it ends in a 0. All right, let's go down to the 6's. The 6 is a new rule that I did not introduce you to yesterday, but I'll look at it with you real quick. It says if the number is divisible by both 2 and 3. All right, so the number that you see here I have is 42,870. Well, I know that this number can be divided by 2, and the reason I know it can be divided by 2 is because it ends in a 0. Okay, so 2 is a factor. 3, remember the rule for 3 is I do this. And I add them up. And if I have 21, can 21 be divided by 3? It can, 7 times. So I know 3 is a factor. If I wanted to look at the next number, I could look at 4. How do I do the rule? The 4's rule? The 4's rule says to look at the last 2 digits. So I'd look here at 70, and I have to decide whether or not 70 can be divided by 4. And 4 does not go into 70, so 4 wouldn't work. 5 would work because it ends in 0. So I've got 5 here. Let's put this little mark here. 6. Well, according to this rule here for 6, the rule for 6 is if the number that we have is divided by both 2 and 3, which we proved it is, then it is also divisible by 6. So I can't know if it's divisible by 6 unless I've done 2 and 3 first. Okay, well, let's look at what 7 says. 7 says if the last digit of the number is doubled and subtracted from the rest of the number, and this difference is divisible by 7. Now, this rule gets a little lengthy and hard to understand, and so for me, unfortunately, I think that the 7's, the best thing to do is just to go ahead and divide by the number 7 to see if it works. So what I would do, okay, so for me, the easiest thing to do is just to go ahead and do the long division problem. And I'll show you why. And if you notice, as I'm solving this, I notice that this is not going to come out even, okay? So I have a remainder. So this number would not be divisible by 7. So I couldn't list it. Now, according to the rules here, if the last digit of the number is doubled and subtracted. Well, if you notice, my last number here is a 0. And if I double 0, guess what it is? It's still 0. And then I have to subtract it from this number, which basically means I'm still going to end up doing this long division problem anyway. So this number here, 7 is the one that usually you just have to divide by it because it makes it a lot easier. So if I go back to my original paper that we were making a list, on this I would not be able to put the number 7 here going into this answer. Okay, the next number we have, remember, is the 8. And to review the 8s, it says if the last 3 digits of a number are divisible by 8. Well, remember, here's the number we had. So I have to look at 870 and see if it's divisible by 8. All right, well, let's go ahead and just see if the last 3 digits are divisible by 3. 8 goes into 8 once. Doesn't work, so we'll bring down the 0. How many times does 8 go into 70 without going over? It looks like 8 times, which is 64. And once again, I have a remainder, which means this does not work. So when I make my list, I cannot add the number 8. All right, so I do not get to add the 8 for this number. Let's see what the 9's paper says. The 9 says if the sum of the digits is divisible by 9. Well, we already found the sum to be 21. 21 was divisible by 3. It worked. 21 cannot be divided by 9, so I can't add 9. And the last number that we're going to look at for today is if the number ends with a 0, which it does, and so I get to add the 10. Now, these rules are just to help in case you want to find something quickly or find out if a number can go evenly. Sometimes, for some of you, it might be easier just to go ahead and do the long division because sometimes the divisibility rules, if you don't have them in front of you like this, you can get confused and forget. Okay, so if you ever get to a point where you're not sure, then just go ahead and set up long division like this.